I'm going to try to keep this simple. I made a couple of videos earlier, but they were too long. So, the solar system. Let's do a little intro here. So this is the relative sizes of the planets compared to each other. So this is from NASA. NASA has just a bunch of amazing stuff on their website if you ever want to go explore it. So this is Mercury, Venus, Earth, and Mars. And we have Jupiter, Saturn, Uranus, and Neptune. They throw Pluto in there, but it doesn't really count. And so you can get an idea, okay, if this is the Earth, this is how big the other planets in the solar system are. You can see they fit kind of nicely into two groups. We have sort of four that are about the same size here, and they also happen to be next to each other in the solar system. And then we have four much larger ones that kind of fit together and are kind of seem like they fit in the same category. And so it's really nice that they fit into nice two sort of very distinct categories. Now down here, we can see another way in which these two groups of planets sort of naturally fit into two groups. Here we have Mercury, Venus, Earth, Mars, and you can see, we know that, Earth is 93 million miles right here from the Earth to the Sun, so it's very, very big. But compared to the other planets, these four are very close to the Sun, so they're sort of all bunched together, close to each other and close to the Sun, right? And about the same size. So these are the inner planets, we call them. Sometimes they are called the terrestrial planets. Terra means Earth, so terrestrial means Earth-like. And then we have, Jupiter, Saturn, Uranus, and Neptune much further away from the Sun. So they're all really far away, and they're also far away from each other. They're very far apart compared to the inner planets. So these are called the outer planets, naturally. Sometimes they're called the Jovian planets. Jovian means Jupiter, and Jupiter is kind of the main, representative of this of these planets. And occasionally they're called gas giants, which don't really like that name quite as much. I'll talk about it more later. Okay, so that's the solar system. Didn't have to skip some of this. Models of the solar system. I'm going to try to keep this quick and simple. All right, so geocentric. Need to know this term. All right, so geo means Earth, centric means, well, center, right? So the Earth is at the center of the solar system in these models. Right? So the Earth is at the center. It's totally standing still. It's not rotating or anything. And all the planets and the sun and the moon and the stars go around the Earth. Now you might say, well, that's ridiculous. I know that's not true. Well, for most of human history, that has been what people thought. And there are actually really good reasons that people thought that. So I'm just going to go quickly over just two basic models of the geocentric solar system, and really I should say geocentric universe, because the Earth was, the solar system was the universe, really. And so the Earth was the center of the universe in these models. So we have Aristotle in the ancient Greeks. So Aristotle was kind of the big figure of the day. And his model basically said, look, here we have the Earth at the center, and then we have all these other astronomical bodies, planets and so forth, going around the Earth in perfect circles. Now, how did they go? How did they, move around the Earth? Well, they were carried on these crystal spheres. So they had these invisible, transparent crystal spheres that just sort of rotated, and they carried all these sun, moon, and the planets around Earth. Now, you might say, well, what about the stars? Did each star have its own? Well, not all the stars were on the same crystal sphere. It was the outer one. And so the stars were just sort of carried together on that last sphere. And it was thought that we know now that the stars are incredibly far away, like way further away, much further away than all the planets, right? Well, they just thought that, Saturn was the last planet they knew, and a little bit beyond Saturn was the stars. So that was it. That was the universe. So it's a nice, simple model. I kind of like it. Here's another representation of it, more in the horizontal mode. You can see we sort of cut the spheres in half here so you can see them. They didn't know about Uranus and Neptune, by the way. Those were only discovered later when we had telescopes. So Saturn was the last planet. All right, now there was a problem with the Greeks' geocentric model. And what it amounts to is that the planets do not move that way. What do I mean? Well, if you watch the planets night after night, the reason they're called planets, planet means wanderer. So the stars sort of never move. They just go around once each night and they stay the same positions. But the planets move night to night. Okay, how do they move if you watch them closely enough? Let's go to 105 here. So this is Mars. And if you watch Mars night after night for a long time, okay, it's moving across the sky. It's wandering, that's why they call it a planet, right? But then it does something weird. It slows down, it goes backwards, then it slows down again, and it goes forward again. Well, that seems strange. And if Mars were just carried on a nice crystal sphere and did a perfect circle, well, it wouldn't do that. It would just go straight across the sky and around, right? So that was a problem. All right, I'm going to stop this video here.